Hello everyone, welcome back, and we're gonna start the 13B today, and then for hopefully the all makes sense for 13A. Now we're gonna do conditional probability and independence events. So first thing first, the conditional probability of event A, given that event B is already occurred. So I want you guys to remember that is using probability A given B, which is probability of A intersection B over B. And formula may rearrange as well. Use the multiplication rule, which is we find out our A intersection B equal to probability A given B times the probability of B. So if the B given A, so that will be the opposite way. So which is B intersection A over probability of A. And then some questions like that, we're going to using some law of the total probabilities. So in certain terms, the probability of the rain on Monday is 0.21. The rain on Monday, then the probability of the rain on Tuesday will be 0.83. It does not rain on Monday, then raining on Tuesday is 0.3. And for given weeks, find the probability. All right, first one. So we're going to find both Monday and Tuesday. So what we do the first question is, very good question for that to do is we can create our tree diagram. So first one, rain Monday and Tuesday. So if you rain on Monday, 2.1 and 0.79, which is M representing the rain on Monday, T representing rain on Tuesday. The situation we can try to use we can check our probability to adding up to 1. And the second one, so if you rain on Monday, you rain on the Tuesday. So you rain on Tuesday. Sorry, my bad. If you rain on Tuesday, will be 0.83. So which means that if you rain on Monday and Tuesday will rain on 0.83. And by 0.17 will be not rain. But if you not rain on Monday, they said 0.3 for Tuesday raining, so 0.377, and T not raining will be 0.3. So probability of T intersect M will equal to so we can use A given B multiplied by B, so which is so A given B, so which is we using 0.21 multiplied by 0.83, and the probability of T intersect M will be 0.21 multiplied by 0.17, and the probability of not raining but Tuesday will be 0.79 times 0.7, and probability of not raining on Monday and also not raining on Tuesday will be 0.79 times 0.3. Yep. So for question A, probability of you raining on both. So you're raining on both, which is we using the 0.21 times 0.83, so that equal to 0.174. Yeah. And for question B, so we want to find the probability of raining on Tuesday. So we're just adding those up. So which is we're gonna say probability of T will be probability of T intersect M plus probability of T intersects not M. Yeah. So that equal to 0.174 plus 0.237. So that equal to 0.4113. So that's 41% the raining on Tuesday. And I want you guys to copy this one down, the law of total probability. So that's how you're adding them up in the question B. Hopefully that makes sense. And another question here. We're gonna do this question in the during the class. So hopefully that all makes sense for you at the moment, but that's okay. And you can try yourself first and let me know the answer. And there is example 3 I'm gonna try to do. Now we're gonna using some tables. So first one, this is secondary college year 10 to year 12. 400 people are being served for the education canteens. Results showing a poor, good, and excellence. So here is what's the probability students are choosing. So question A, the probability of year 12. So that equal to, we have 80, so which is 80 divided by 400, that's 1/5. So 20% if you want to say. Yeah. And year 12 ranked canteen are excellent. So now what we do is probability of 12 intersection the excellent. So probability of this is 35 over 400. So that equal to 7/80. Yeah. And question C. So we know year 12 for the given the rate is excellent as well, give the rate as excellent. Given. So now we're using the given. So probability of year 12 given excellence. So that equal to probability of 12 intersection excellent over probability of excellent. So what does that equal to? So probability intersection is 35 over what's the probability of excellence, so which is 160. So that's it, and that equal to 7/32. And the probability of D, now we say rate excellent given for year 12. So now we do the opposite way. Probability of A intersection 12, that equal to probability of A intersection 12 over probability of 12. So that equal to 35 over 80 students. And now you had the given 7/16. So you can say they're not equal to each other, okay, C and D. So they all had the answer, but it's differently. Now what we do is we're going to say independent events. So what's independent events in here? So A and B, and they all has a probability, and then following the conditions, which is 3 rules for the independence. The first one, probability if A given B, that means equal to probability A. Probability of B given A, that's equal to probability of B. But intersection, that means you multiply by those two. Yeah, if you say the independent events. So if they say in U, normally they say that are independent. So Monica remember to do the questions, which is 70%, and Patrick remember to do the question 0.4. This is independent. They not relate each other. So question A, the both will do the question. So if they both are due question, that means you are intersect. The both are due questions. So Monica means M and P is Patrick. So make sure you write down that number, and then that equal to probability of M multiplied by probability of P that equal to 0.4 times 0.7, that equal to 0.28. And question B, so Monica will do her homework, but Patrick forgot. So probability of intersection P forgot, which is equal to probability of M multiplied by probability of P forgotten, so 0.4 times 1 minus 0.7, which is 0.3. Oh, sorry, Patrick is 0.4. My bad. So 0.7 times minus 0.3, 4. And now is 0.7 times 0.6, so that equals 0.42. Yeah. Hopefully that makes sense. And then this is all about the independent events, and I see you guys are in 13C.